Hey y'all, and welcome to the final episode of the Basics of Building an FTC Robot, presented by 17097 Protostars. Once again, I'm Ty. Last episode, we talked about the driver station and what is part of your driver station with controllers, a driver hub, an external battery, all of that stuff. But today, we're finally getting into the programming, so let's dive in. First, we're going to start by opening our browser and going to the GitHub for the first tech challenge FTC Robot Controller. And we're linking to this in the description of the video. We're going to press this green little code button and a menu pops up and then you can select download zip. Next, we have to download Android Studio. So I'm going to search Android Studio download and select the top result there. And then you're just going to select the current edition of Android Studio. Agree. Yes. Perfect. There we go. Downloading. Now, just as a disclaimer, we are using an older version of both Android Studio and the FTC Robot Controller, but really it shouldn't make any difference. They're pretty similar anyways. So we're going to unzip the or extract the file that we just downloaded, the FTC Robot Controller. Now you're going to launch Android Studio and you're going to open the FTC Robot Controller. And it should look just like this. Now that we've opened the FTC Robot Controller in Android Studio, we're going to right-click here and then we're going to select New and go to Java class. Select that. And we're going to name our Java class. Let's go with center stage robot.java. Perfect. And it should just pop up like this. We're going to do this again. We're going to create another Java class and name this one, let's go with Drivetrain.java. We're going to make one more Java class and we're going to name this one Teleop.java, so Teleop.java. Okay, one more. We're going to make a Java class that is titled Autonomous for the autonomous period. All four of these are required for making a fully programmed and functional robot. This first section of code simply imports the packages that we need to run the robot. So it's hard to explain them all. It's not that important. Don't worry about it. But just make sure you have all of those. The next section defines each of the motors and servos that you have. So on our robot, dummy, in this case, we're keeping it really simple, and we're just going to have 2 motors for the wheels and 2 servos for the grabber and lifter. So we just have, right here you can see a right and a left motor, and a lifter servo and a claw servo. So if you have more motors or servos, you can just define them the same way that I'm defining them here, with additional lines of code. And the last section defines the hardware map so that the driver station can be configured and understand, and it tells the driver station where and what each motor and servo is. So now we're going to switch to the Drivetrain.java program, and we're going to have the same packages imported and the same motor and servo definitions. However, we're going to add one more line under this definition section for power. So we're going to define this, this double variable as power. Next, we're going to define which directions you can drive and which directions you can turn. So under drive, we have forward and backward because our robot cannot go sideways. It can just go forward or back. And under the turn section, we have spin left and spin right to rotate. Next, we're going to create the hardware map again, just like we did under the center stage robot program. And then next, we're going to switch the directions of one of the motors, because if we had both motors facing the same direction, then we'd be perfectly okay because they'd be both spinning in one direction. But if you flip one over like this and have two wheels on the outside, like a normal robot would have, they're spinning different directions. So you need one of them to be automatically negative so that they line up together. So we're going to make the left motor negative. Next, we're going to create a new function called Drivetrain that's going to be used in the autonomous.java program. So you're going to have the variables power, time, and drive direction. And don't forget this throws interrupted exception, because if you forget that, you're going to get a ton of errors and you'll get really, really frustrated. In this program, we're going to have an if-else program or statement, and in there we're going to have it say if the current drive direction is backwards, switch the power to negative, and if the current drive direction is forwards, then just use the normal positive power. And then in the next line, thread.sleep, it's going to just go forward for a certain amount of time. That's a variable at the beginning of the function. And then once it executes that time, we're going these two lines right here tell the robot to stop. Then we're going to create another function for turning instead of driving. So under the turn function, we have the same variables. We have power, time, but in this case we have turn direction, not drive direction. And don't forget that throws interrupted exception. We have the same if-else statement on the inside of the program that switches the power if it needs to, except this time instead of backwards and forwards, it uses spin left and spin right. And then we have a thread.sleep where it tells the program how long to run, and then once that time is reached, it tells the function to stop again. So if we move over to our dummy Teleop program, we're going to start by importing a couple libraries and packages. A little different than the other ones, but yeah, just use these ones here. And then on line 7 here, we have we're naming what you select on the driver station for what program you want to run. So in this case, on the driver station, we would select dummy Teleop to run this program. Next, we're creating the dummy Teleop program or function, and the rest of the entire program is going to be under this function. The next line here, we have we are defining the robot, because Java is an object-based language, and so you always have to tell the program what is doing the action, not just to do the action in general. Okay. And the last thing we need to have here is the speed. So we're going to set the speed at 0.5 just to get started. And basically what will happen is when you're on the controllers and the joystick is at the full distance, it will be going 0.5 speed. And then if you do a little less on the joystick, it'll multiply that by 0.5 and use that speed. And we can change this 0.5 to anything from 0 to 1.1. So it's like percent, but instead of percent, it's in decimal form. And 1.1 is like 110%. So if you just want to give it a little extra push, it can do that. Next, we're going to start with writing @override. And then after that, we're going to create a function for initializing the robot. And this first line here initializes the hardware map. And then the next two lines tell where the servo should start. So servos go from 0 to 1. So we're just going to start at position 0 to start off here. Then next, we're going to do @override again. And basically what those overrides do is it says at the end of this function, stop and wait for the play button. So if you hit initialize, it'll initialize the robot and then stop and wait for you to actually press play. So then once you press play, it continues the program. We're going to start by defining the two controller joysticks. So each controller is going to, each joystick is going to control one side of the robot. So on gamepad 1, we have the right stick control the right motor, and the left stick control the left motor. Then in the next section, we tell the robot how fast to move. So you can see here it says set power to the amount that the joystick is being pressed, which is L, times the speed that we set earlier, which currently is 0.5. And then same thing with the right. Now we're going to move on to the functions for gamepad 2. Now keep in mind, to make sure that the program knows which controller is 1 and 2, you need to press buttons on the controller to say this one is 1 and this one is 2. So for controller 1, you're going to press start and then A. And for controller 2, you're going to press start and then B. So that way the program knows and the robot knows which controller is doing which functions. So if we take a look at this next section, we're going to use the bumpers, the left and right bumpers on gamepad 2 to control the lifter servo. So basically when we press the left bumper, the arm will go down and be ready to grab things. And if you press the right bumper, then it will go back up. And then in this final portion, we have the claw programming. So if we press A, then it will close the grabber. And if we press B, it will open the grabber. All right, we have one more section to go through, and that's the autonomous section. So under the autonomous section, we're going to import these libraries, and then I believe it's the same as the driver station, or driver Teleop. I believe it's the same as Teleop. And then we're going to name the autonomous program, what it'll be named on the driver station, so we know, hey, we want to run the autonomous. Let's select, in this case, it would be dumb-e autonomous. And then now we're going to create the autonomous program. And under that, we're going to immediately define the robot, because as I said, we need to make sure the program knows what is executing the action. So in this case, it's going to be robot, and then from everything after that, it'll be robot dot blah, blah, blah. And then we have that override again. And then we're going to initialize the hardware map again, just like in the Teleop. This is all going to be very familiar. And then next, when you're waiting for the game to begin, it'll say press play to start op mode. And then once the game starts, you would press play, and then you can see here's the wait for start. And once you press the start button, it will run the program. And in this case, the program is simply going to drive forward for 3 seconds and turn for half a second. Now, something important to note here is that the program uses milliseconds. So we're writing 3,000 milliseconds instead of 3 seconds. If you write 3, it's going to go forward for 3 milliseconds, and you're barely going to see it move. So make sure that's always, always, always in milliseconds. And if you have obviously you're not going to want it just to drive forward and turn in a normal program or in a normal autonomous. So you just have more lines of code under that section telling it what actions to execute. Thank you so much for watching this episode of the Basics of Building an FTC Robot. If you stuck with us for the full 7 episodes of the series, we really appreciate it. And stay tuned, we are also going to be launching an 8th episode showing off our finished robot and programs. So, thank you guys for watching, and make sure we're going to keep posting videos this season. We're not going to stop here. And so, keep up with us. A great way to do that is to follow us on both Instagram and X, and then subscribe to us on the YouTube channel, and they just really help us out a lot. All right. Thank you, everyone, and good luck building. So we're going to make the right joystick be stick Y and the left controller right stick. I said that wrong. Are they both stick Y? What's the Y mean?
Y, up and down. X, left and right.
Got it. Let me do that again.
Yeah.